Okay, so this first example here, we have evaluate each argument. It says, all U.S. voters must register. All people who register must be U.S. citizens. Therefore, all U.S. voters are U.S. citizens. So let's take the very first premise. That's this one right here. And that's the only one we're going to look at right now. All U.S. voters must register. I'm going to make an Euler diagram for this. So my first circle is going to be U.S. voters. The next part of it says all must register. So therefore, that's going to be inside a larger circle called register. So this diagram illustrates the very first premise.
What if it was the vice versa? The small one was registered and the big one was US.
Then it would mean that some U.S. voters don't have to register to vote. Okay? But in this case, they all do. Okay? Okay, the next premise, all people who register must be U.S. citizens. So we're going to add to this illustration the next premise. I'm going to do this in red. Because all that register must be U.S. citizens, I'm going to circle around that and put U.S. citizens. There is no other way for me to make this diagram. So, if you look at the therefore, it says all voters are U.S. citizens. Can you see that by this chart? Here's your U.S. voters. It's inside the U.S. citizens bubble. So this is a valid argument. Now in this one, the first premise says all clocks keep time accurately. So all clocks keep time accurately. So the first premise I'm going to write down is, first of all, a clock. I suppose you could draw it if you really wanted to. Okay, clocks. And then that's going to be within the circle of keep time. I'm just going to call it KT for keep time, just because I'm abbreviating. Okay? So that's the first premise. The second one says, all time measuring devices keep time accurately. Okay, so here's a possibility. You could have something called clocks, and you could have something, a time measuring device like this. That's one possibility. You have the possibility of this. Where there might be some clocks and time measuring devices. I can think of one real life example that's a time measuring device that is not a clock. Can you guys think of one? A sundial? I would argue that's a clock. What kind of watch? No. I would argue that a clock is not a time measuring device because it tells you the exact time and you actually go through the calculations of how long it's been in your head. Okay? But a stopwatch is a counterexample, and maybe the nicer ones have a clock on them, but I know the cheapo ones do not. Okay? So this could be an example of a stopwatch, or right here could be an example of a stopwatch. Okay? So therefore, all clocks are time measuring devices. Well, no, this one says some are, and this one says none are. So this would be an invalid statement. right, so the first premise says all humans are warm-blooded. So I'm going to draw a circle and label it humans. Okay? And then I'm going to put a bigger circle on here and call it WB for warm-blooded. The next premise says no reptiles are warm-blooded. Where would I put that? Yeah, outside. I could put reptiles right here. And it doesn't touch the warm-blooded because there's not any that are warm-blooded. Okay, so the therefore statement. No reptiles are human. Based on this diagram, is that true? Yes, so it's valid. Okay, so we are looking at all professors are wise people. So if I were going to draw a picture of that, first of all, I'm going to put a circle called prof for professors. Okay, and then inside of that, I will say wise. Okay, and then it says some wise people are actors. Okay, there might be more than one way of writing this. Where would I put the actors circle? It says some, so not all actors are wise, but some wise people are actors. So I'm going to put, my first one, I'm going to put profs right here. And I'm going to put my actors like this. That's one possibility. Okay, so let me go back and make another possibility. I could have this. Wise. Oops, I didn't want that. And then I could have my profs actually touching the side here. And then I can actually have my actors going through both. I have two diagrams here. Do they both fit the therefore? No. The only one that fits the therefore is the second one. This one fits the therefore, but this one does not. So this is an invalid argument. Okay, if you can come up with another one that does not fit, it's invalid. Okay, so now looking at this one, it says all A are B, no C are B, and all D are C, therefore no A are D. What are my premises on this? How many do I have? I have 3. Here's 1, here's 2, and here's 3. Okay, so I'm going to do the first one. All A are B. So this is my B, my A is inside. Anybody disagree with me? Okay. The next one says no C or B. Where would I put C? Outside. And then the last one says no D or C. So I'm sorry, all D or C. I said it wrong. So that would go in here. The answer says, thus, no A or D. Is that true? Yeah, so this is a valid statement. There's no other way to write this one. All right?